Today we're doing game theory, and in many ways, game theory is kind of the opposite of probability. Probability deals with unknown outcomes of events. However, that unknown outcome is driven simply by random chance. Whereas game theory deals with unknown outcomes. However, the variable there is human decisions. So think of a game of like uh, some kind of like dice rolling game where it's just totally random, right? Versus a game like chess. You don't know what your opponent's going to do. There's a wide variety of options that they could make at any given moment, but it's not random. It's chosen by the opponent, and what you do impacts what they do. So game theory is all about that sort of stuff. Um, the original setup I had for this was to play a game with basically like units of money. And we would go through all these different examples of game theory in the classroom. However, here I just have my wife, so I'm just going to do a couple of a few of the examples, just so you can get an idea of kind of what some of the game theory ones will be like. The classic example, the one I want you to do at home, is stags and hares, so we'll start with that. And in this one, it's like you and I are going to go out hunting,
Okay.
and um, we have two options. You can go hunting for a stag, or you can go hunting for a hare.
Okay.
If you go hunting for a hare, there's plenty of hares running around. You're going to be successful. You're going to shoot the hare. You're going to bring it back. You're going to get $3 worth of meat and hide out of the hare.
Sweet.
So that's pretty good. You get 3 points for the hare. If you go hunting for a stag, the stags are like super wily and they're really skittish, and so basically you need to work as a team. And it's impossible to bring down a stag if you're just by yourself.
Okay.
But if we're both working together to bring down a stag, then we're successful. The stag is, tons of meat, and the hide's really valuable, and so we get $5 each if we were able to bring down a stag.
Okay.
So that's what this table here is representing. This is player A, player B. I'm player A, she's player B. If I choose stag and she chooses stag, we each get $5. If I choose stag and she chooses hare, this is the downside of choosing stag, is since she's not there to help me, I get nothing. I get $0. But she goes and gets her hare because it's easy to get a hare, so she gets $3. Similarly, if she chooses stag and I choose hare, she gets nothing. And then if we both choose hares, we both get $3. The trick with this game is if I know she's choosing stag, then it's pretty easy for me. Do I want $3 or do I want, $5? Well, I want $5, so I'm going to choose stag as well. So the trick with this game is you each choose without the other person knowing. You could like write it down on a sheet of paper and hide it, and then reveal it at the same time. You could do rock, paper, scissors. We'll probably just do rock, paper, scissors. What?
Why wouldn't you always choose stag?
Because if the other person chooses hare, you get nothing.
But if you both choose stag every time, you get more.
Yeah, but the other person might not choose stag. That's the whole point of all these game theory. Most of these game theory ones, there's some optimal thing where if everyone just cooperates and does the right thing, then we all turn out really good.
Okay.
But
Okay.
yeah, you'll see. So that's why we're doing the example. We're gonna play rock paper scissors style, where we go rock paper scissors. You get two options for this instead of three. Unlike rock paper scissors, this is hare, and this is stag.
Oh, sorry.
Okay, does that
chose
work?
Salamander.
So you can't do paper in this case. We'll just go rock paper scissors. In this case, you chose stag, I chose hare.
This isn't choice. This is random.
No, what?
This is random.
What's random? You're choosing whether or not you go stag. Are you going to hunt a stag, or are you going to
Okay,
hunt a
I
hare?
got you, I
You
got
don't choose at random. You're physically controlling what.
Okay. Okay.
Okay. So, what should we say?
Which
Rock
is
paper
which?
scissors.
Which is
Or-
which?
This is stag.
Stag.
This is hare.
Hare.
Hare. This is
Bunny ears.
bunny ears. Exactly.
Okay.
So this is 3 points, guaranteed. This is 5 points if we fist bump, and 0 points if the other person does bunny ears.
Okay.
Okay?
Okay.
So we're gonna go 1, 2, 3, and we're gonna reveal our answer on 3.
Okay.
Like rock, paper, scissors. So we'll do it.
But no paper.
Yeah. Okay. Ready? So we'll go like this. Rock, paper, scissors.
Why would you do that?
Oh, so I went hair, so I get $3. Hooray. You went stag, so you get $0. She gets
It's not
$0.
a competition, Robert.
Okay, you ready? Rock, paper, scissors. Oh, look at that. We both went stag. So therefore, we both get $5. Hooray. 5 for
Give
you.
me those.
And 5 for me. Okay, ready to do it again? Rock, paper, scissors.
I don't trust you.
Well, you get $0
My
again. That's
children
so
are
bad.
going
1, 2,
hungry.
3 more dollars for me.
Why would you choose that?
Ready? Rock, paper, scissors. Oh, why do you keep running after stags? I'm making out a ton of money. So then you play this 10 times. Who has the most money? Let's see. I have 5. This is only after 4 rounds. I have $14. Woo-hoo-hoo. Look at all that money I got. How much money you got?
I have a very noble $5.
She has a very noble $5. Well, okay. I played this game poorly for a reason, and that's to show that there's multiple outcomes to this. If since I love my wife, if this was real life, obviously I'd be going stag every time. And that's the ideal, is if we just both go stag every time, we both make out really well. There are other situations, and you'll see this one in a second, where that's not true. So, for example, I'm going to skip ahead to this this Nash equilibrium game. So in this one, each person chooses a number in secret between 0 and 1. Okay?
Okay.
Then we'll reveal the numbers. Both players receive money equal to the lowest number chosen.
Okay.
So in this case, if we both choose 10, right?
Okay.
Then we each get $10. Bam, easy, right?
Okay.
But if you choose 8 and I choose 10, we each get $8. Right?
Okay.
But here's the trick. If we choose different numbers, the player who chose the higher number gives $2 to the other player. So if we both choose 8, or if you choose 8 and I choose 10,
Okay.
we each get $8, and then I have to give you 2 more.
Okay.
Right?
I don't like these games.
Yeah, I know. And if I was playing with her that wasn't a demonstration, we'd always just choose 10 and we'd all be happy. But you know I'm not going to do that because that would make a really bad example for the kids in the video, the niños. Okay, so we're going to choose a number between 1 and 10.
It's funny listening you try to head off trouble.
This first one will be pretty arbitrary, and then
Okay.
we'll see. Okay?
Okay.
And then on the count of 3, reveal. Ready? 1, 2, 3. Oh, so I chose 6 and she chose 7. This is pretty good for me. So we each get $6 because 6 was the lowest number, right? And then the player who chose a higher number gives $2 to the others. So I get 2 of her dollars. So not only do I get the 6, but I also get 2 more from her. So I get 8 total. What does she get total? She just gets 4. Yeah. So we'll do it again. You ready?
Okay, ready.
On your mark. Get set. Go. What'd you pick?
10.
10. I picked 10 as well. Hooray. We both get $10. Neither one. Here, you get $10.
Thank you.
Neither one of us
Feed
gets
my babies tonight.
totally in trouble. Okay, now we're going to do this again. Ready?
Okay.
Set. Go. Oh, I picked 0 this time. So we each get $0. And then she has to give me $2. So not only does she not make money, but I make some money off her. Oh, that's nice. Okay, we'll play one more time. Ready?
Why would you play like that?
Set. Go. Oh, I picked 0 again. She owes me another $2. what can she do to not give me $2? I wonder. Ready? We're going to play one more time. Ready, set,
I don't like these games.
go. Oh, she picked 0 as well. So we both get no money. And
That's
neither
way
one
where
of
I
us.
said both of us
Hooray.
picking 10.
Okay. So the point here is that no matter what she picks, I want to pick something lower to optimize the amount of money I get. So if I know she's going to pick a 10, if I pick 9, I get $11, right? And she gets even less. If no matter what her choice is, it's always better for me to go lower. And in fact, the only value you can guarantee not losing money on is 0. Because if she picks 10 and I pick anything else, or like if I pick 0, she loses $2 just straight up. So the rational way to play, right, is to pick 0 because that way you can't lose any money. And sometimes you get $2. However, if you can find someone to cooperate, someone who's nice to you, someone who's altruistic, you can both just pick 10 every time. And each time you pick 10, you both win and you both get a ton of money each time. So it's much better to cooperate, but the cold logical choice is to not cooperate. This brings us to our prisoner's dilemma, which is kind of like the stag and the hare, but again, same situation here, where if we cooperate, there's a benefit. If we don't cooperate, it's detrimental to us. And if it's something in between, then one person really benefits, the other one doesn't. In this example, we both got caught, and there was a crime nearby, and it doesn't even really matter if we were both criminals who did it or if we didn't. All of the evidence and conviction rests on whether or not we accuse each other of doing it. So, for example, they'll separate us, they'll put us in separate rooms, and they'll just ask me, hey, did your wife commit this crime, right? And I'll say, yes, she totally committed the crime. Or I could say, no, she did not commit any crime at all. She's totally innocent. They're not even going to ask me about myself. They're going to do the same thing with her. They'll ask her, oh, hey, did your husband commit this crime? And she's going to say, no, he's innocent. Or she's going to say, yes, I saw him commit the crime. It's all his fault. If I say she's innocent and she says it's my fault, who's going to jail? I'm going to jail, right? And then if vice versa, if I say it's her fault and she says I'm innocent, I get off scot-free because clearly I'm innocent. Clearly she's the guilty one, so she goes to jail. So in this case, we'll say go to jail for 5 years. We'll lose $5. And then I got to pause for a second. And then the final option is if we both accuse each other. So I say, oh, she's guilty, and she says, oh, he's guilty. Then the cops are like, okay, well, I guess they're both guilty. They both deserve part of the blame, and we both go to jail for a little while. If we're both say the other person's innocent, so I say, oh, she's innocent. She says, oh, he's innocent. Then the cops don't really have enough to convict us for the crime, and they get us on just criminal mischief or something, and we pay a fine or whatever it is. So we don't get off scot-free, but it's much better if we're both innocent versus if we're both guilty. So we're going to play this one again. Okay? Same deal as rock, paper, scissors. This one is...
No.
This one is... What's the... I don't know.
Innocent or guilty?
This was the cooperative one, right? So we'll do this is innocent, and this is you're guilty.
Okay.
Right?
Innocent,
Like the...
guilty.
Okay. Ready? So we're gonna do this.
Okay.
Mark, get set. Okay. So I said she's guilty, right?
Wait,
She said I'm innocent. So I get off scot-free. I don't pay any money, and she owes the bank $5.
Really?
So
I'm
$5.
just trying to get out of taking care
No,
of the
$5.
kids for 3 years.
$5.
No, you definitely said jail.
Well, okay, you go to jail for 5 years, which is represented by losing
Wait, I
$5.
said 6.
Okay, no, that's fine.
Okay.
Okay, we're gonna play again. You ready? Set. 1, 2, 3. This time we both said we're innocent. So we each owe just $1, right? So as a whole, we're losing less money this way than if we convict her, right? Because we're just losing 1 total, or 2 total as a group, than if we lose 5 total as a group. But I lost more doing that. Okay, we're gonna do it one more time. You ready?
Ready.
Okay. Rock, paper, scissors. Sorry. 1, 2, 3, I should have said. Okay, this time we both say the other person's guilty. So since we're both guilty, we both lose $3. And this is the worst outcome of all collectively. Notice collectively, we just paid $6. Before, even if I just accuse her, we just lose $5 collectively, right? And then if we're both innocent, we'd both lose $2 collectively. So it's much better if we cooperate. And of note here, let's say I know she's going to go guilty. If I know she's going to say guilty.
Well, I know you're going to say
No,
guilty.
no. Here's my options.
Okay.
If she says guilty, right? That means I can either say that she's innocent, I owe $5, or I can say that she's guilty, I only owe $3. So if I'm just looking after my own self-interest, I would clearly say guilty, right? If I know she's saying that I'm guilty. If she says I'm innocent, again, I have two options. If she says I'm innocent and I say I'm innocent, I lose $1, right? But if she says I'm innocent and then I say she's guilty, I lose nothing. So if I know she's going to say innocent, it's still in my selfish best interest to say the other person is guilty. So what's unique about this one is no matter what she says, the best option, strictly from a monetary standpoint, is to say that she's guilty, right? However, that'll put us both saying guilty each time, and we'll both end up at that one where the system has the worst possible outcome of us both losing $3 each time, or six collectively. Whereas if we both go innocent, we both benefit by losing very little. Okay, so we'll pause it right there. That's kind of the lesson behind a Nash equilibrium. Go watch the movie Beautiful Mind if you want. Go check out
the book.
go check out some of these other ones. Please play the hair game with your family, or maybe you can try some of these others as well. But
Bye.